Today we are using the Ethereum data service for storing and using various encodings in the Ethereum virtual machine, the EVM. This is the EDS application, where we can browse the EDS-based smart contract that contains the encodings. The basis set is where the encodings are stored. By name, base, and alphabet. So we have base 2, base 8, 10, 16, 58, 27, and the ASCII encoding. And this is the DApp for interacting with the encoding decoding API of the EDS-based smart contract. We can transform 256 from base 10 to base 2, and this is the answer, or to base 16, or to base 8, and so on. So this encoding decoding service is on-chain and done by pure functions. And currently it can support any numeration base smaller than 256 with any character encoding. N records, hence n types of encoding, is equivalent to n multiplied by n-1 transformations from one base to another, and the equivalent of 2 multiplied by n encodings from bytes to a base and decodings from a base to bytes. It can support encodings for IPFS, Bitcoin, GeoHash, so developers can have on-chain standards for verification of off-chain encodings and decodings. One major advantage for the EVM is benefiting from string compression to lower storage costs. Let's take this long word and use base 27 to encode it to a hexadecimal value, so base 16, that can be stored on-chain. So, pneumo ultra microscopic silico volcanoconiosis can be encoded to fit into 54 hex characters, which means 27 bytes. So it can be stored in a single 32 byte storage slot on the EVM. Now we take this hex value and decode it again from base 16 to base 27, and we get our initial string, which has 45 characters. This means we need 45 bytes to store this exact string with ASCII encoding, which amounts to 2 storage slots. But we can write even more. And with 30 bytes, we are still within 1 storage slot. So encodings allow for significant gas savings, but the encoding algorithm and alphabet must be on-chain for it to be trusted. And the system is flexible. Records can be modified and more encodings can be easily added. Let's take base 64, and in Wikipedia we have the alphabet for base 64. All we need to do is transform it to ASCII codes in hexadecimal format. So this iterates on each character, transforms it to ASCII, and then to hexadecimal format. And we take this and go to our EDS app, to the basis set, and simply insert it. We confirm the transaction. And now we go back to our dApp. We can see the record added here already. So now we go back to our dApp, refresh, and now we can see the additional base 64 encoding and use it. The smart contracts containing the encodings benefit from all the advantages of using the EDS system, as we talked in previous videos.